All right, I'm live here with 52 weeks of Swift, back at it with Swift properties today. I'm going to just go through and learn more about Swift properties, and I'm going to start with sharing my screen. Let's go ahead and get that started, and give me a second for that. Okay, just had to restart something real quick, and I'm going to share the screen. Okay, so back here, Swift properties. So properties associate values with a particular class, structure, or enumeration. The stored properties store constant and variable values as part of an instance, where the computed properties calculate rather than store a value. And the computed properties are provided by classes, structures, and enumerations. And so properties can be associated with the type itself as well. So to start with, there's stored properties. In its simple form, a stored property is a constant, right? Or a variable that's stored as part of an instance of a particular class. So that's useful to know. And they can be referred to as a variable stored property. And you can also have constant stored properties. So you can provide a default value for a stored property as part of its definition. All right, so let's go ahead and try this out. And we're going to go ahead and paste this in here. And what do we got? So we have a struct, which is fixed length range, and it's going to have a var first value and a let length. And so then if we go ahead and use a range of 3 items, a mutable variable, we can actually go through here and say fixed length range, first value 0, length 3, and then say range of three items dot first value is equal to 6. All right, let's go ahead and run that. And it looks like it works. Perfect. And so if I go down here and I say stored properties of a constant structure, this will let you create an instance of a structure and assign the instance to a constant. You can't modify the instance's properties even though they're declared as a variable. All right, let's go ahead and try that out. And in this case, we see that there's a let here, range of 4 items. And then in this particular scenario, this will report an error, even though the first variable is a variable property, right? And so in this case, because even though this is a var here, this isn't going to work because the range of 4 items was declared via a let. And so it isn't possible to change it even though the first value is a variable. This behavior is due to the structure being a value type. The same isn't true for classes, which are reference types. Okay, so that's useful to know. All right, lazy stored properties. Next here, a lazy stored property is a property whose initial value isn't calculated until the first time it's used. So you indicate a lazy stored property by writing a lazy modifier. So yeah, I do like lazy evaluation in general because it's a great way to build complex things that are performant. And so in particular, they say lazy properties are useful when the initial value is dependent on outside factors. So this is actually something that I've done with metaprogramming in Python before, is I would have a meta class that would maybe talk to some external resource like a schema file or something like that. And then the entire class structure itself wouldn't even be defined. until I knew what was happening behind the scenes with the schema. And this was kind of a cool little trick that I would do in Python because I could be adaptive to an API that changed behind the scenes. So in this case, this is an example of a lazy store property to avoid unnecessary initialization of a complex class. And so here we go. Let's go ahead and throw all this stuff in here. And let's paste this in. So we have a class. Data importer is a class to import data from an external file. So again, yeah, this is something I've done before in other languages. And so in this particular class here, we say, okay, look, this is going to have all the data, and this would provide some of the functionality so that you would then go ahead and figure out what was in that file, and then go ahead and change the way things are structured based on what is in that actual file. So the data manager class has a stored property called data, which is initialized with a new empty array of string values. So it's pretty cool to know that you can actually do that kind of meta programming or lazy evaluation. So stored properties and instance variables. If you have experience with Objective-C, which I unfortunately do, you may know that it provides two ways to store values and references. Swift unifies these into a single property. So here we go, computed properties. In addition to stored properties, you can define computed properties, which don't actually store a value, but instead they provide a getter and an optional setter to retrieve and set other properties and values indirectly. And so Python does have this as well. There's a properties decorator. And in this particular scenario, we have a struct, a point, struct size, struct rect. And then this is the getter, this is the setter. And inside of this, we go through and we create a square, and we're able to use let initial square center. So there's a lot of code here. And what does it do? It allows us, so it runs, so in this particular example, it says the point encapsulates the X and Y, the size is the width and height, and the rect defines a rectangle. And so in this particular scenario, you could actually, the center property is then set to a new value of 1515. So basically that's a lot of code for building up getters and setters. But if your computed properties setter doesn't define a name, a default value of new is used. So this is a little less code. So here's an alternative version that takes advantage of this shorthand. And so I think less code is better, for me at least. Alternative rect, var origin, var size, var center point. And in this scenario, though, it is not finding those points, which I think are kept. Yeah, so these would need to be defined, the point and size. So I need to put these at the top, I believe. Yeah, here we go. So it's still using the structs point and size, but in this case, it's a little less code in order to do the computed property. There we go. And so shorthand getter, there we go. As well, here's a shorthand getter. We can go ahead and put this in. There we go, compact rectangle. That works. And read-only computed properties. So I do this as well in Python, which sometimes is kind of neat to basically have something that appears to be a variable or some kind of attribute on an object, but you compute it, but it's read-only, so someone can't change it. And so this is a really good pattern, I think, for many scenarios where you basically want to calculate a value, but don't let someone change that value. And so in this case, we say struct cuboid, let 4 by 5 by 2, and then we go through here and print this out. In this case, the volume of 4 by 5 by 2 is 40. And this new structure is called a cuboid, which represents a 3D rectangular box. You can also do observers. And so these would change. These would basically, figure out what's happening. And so you can say a property observer is for stored properties you define, for ones you inherit, and also for computed properties you inherit. And so you have the option to define either of these. Will set is called just before the value is stored, or did set is called immediately after the new value is stored. So yeah, this is definitely pretty fancy programming, but basically sometimes you may want to do some step before you actually initialize a value. And so this in particular would show you how to do this. And so you would say, before I set something, do this, afterwards do this. And here's our code. So it says will set right here, print about to set, did set, maybe do some kind of calculation. So that is a neat little feature of Objective-C here. Property wrappers allows a layer of separation between the code that manages how a property is stored and the code defines a property. For example, if you have properties that provide thread safety checks or store their underlying data in a database, you have to write that code on every property. So when you use a property wrapper, you write the management code once when you define the wrapper, and then you reuse the management code by applying it to multiple properties. And so in this particular example, we have a decorator here. So define a property wrapper, you make a structure, enumeration, or class that wraps a value, and then it ensures that this always contains a number less than or equal to 2. So that's definitely pretty interesting. Go through here, we run this thing. Here's our wrapper. And if you apply this to a property by writing a wrapper's name, then you can actually do this. So we can go through here and we can say struct small rectangle, and then you use this wrapper, which again in Python they call it a decorator. You would say 12 or less var height, 12 or less var width, and so this basically says inserts dimension are always 12 or less. I see. So in this case, even though you're setting it to 24, it's printing 12. So that is pretty slick, actually. I like that. That's a neat little trick here with Objective-C. I'm sorry, with Swift. And you can also use it in this particular scenario as well. So I guess the takeaway here is that this is a nice way to do metaprogramming, right? You're basically really getting into the weeds here and defining the way things are actually executed and injecting logic that can intercept bad values. So you can also set initial values for a wrapped property. So here we go. Here's a wrapped property here, which this could be really handy for web applications, right? Where you put default values in and they don't have to be automatically completed. So you can get a good, or a mobile app, right? This is where this will really come in handy. Maybe it's auto-filled so that the user has a better experience. And then we would go through here, you apply that wrapper, and you could essentially ensure that there's a good story for a piece of code you're executing by using these wrappers. Let's see what else here. So there's a lot more on wrappers here. I think I'll play around with this later. You can project a value from a wrapped property as well, which looks pretty neat. And maybe to wrap this thing up, there's also global and local variables. And maybe we just play around with something a little easier now. So you can use a property wrapper to a local stored variable, but not a global variable or a computed variable. So in this case, we say func small function, and we use this wrapper. And you can also say instance properties are properties that belong to an instance of a particular type. Every time you create a new instance of that type, it has its own property values. So that's pretty interesting. In this case, you can define properties with static keyword. And so in this particular scenario, the idea would be that you could use a static variable, which I guess we could play around with real quick and go ahead and run this. It looks pretty interesting. Querying and setting type properties. So type properties are queried and set with dot syntax, like instance properties. However, type properties are queried and set on the type, not on an instance of that type. For example, print some structures dot stored type property. And here we go. We can go ahead and play around with this thing. Looks interesting. Querying and setting type properties. Uh, and the audio channels described above are represented by the instance of the audio channel structure. So yeah, definitely the properties here appear to be an interesting way to do some more magical things with your code, especially I think in terms of a UX programmer, where this would be where you would use this kind of code quite a bit. Is essentially autofilling values and sharing values a certain way, and definitely something I'll play around with more as I get deeper into Swift. So thank you again for 52 weeks of Swift. I believe next week will be methods, which are pretty fun. Methods are functions that are associated with a particular type. And we'll cover that next week. All right. See you then.